Hi folks, thanks for joining the session. This session is on really understanding the character data types in SQL Server. Most developers that have worked with SQL Server for some length of time have a pretty good understanding of how the strings work, but there are still a lot of things people often don't understand and a lot of misconceptions. So for example, if you see the N in front of a string and you're wondering why it's there, or if you think that in varchar 10, the 10 means 10 characters, this could be the session for you. Now, who I am? I'm Greg. I'm the founder and principal mentor at a boutique consultancy in Australia called SQL Down Under. I'm a long-term data platform MVP. I've been part of the MVP program for over 20 years. And so during that time, I've seen most things people do right and wrong when they're using the product. I'm also part of the Microsoft Regional Director Program. This is, I describe it as a group of maybe 150 very talented people that I'm honored to be part of. And mostly what it does, it gets me on some interesting mailing lists inside Microsoft. I'm a certified master for SQL Server, and when they had that program, I was an instructor in that program. And finally, I'm an author. I write a lot of white papers, ebooks, and tools. And so I'm hoping you'll think I'm well placed to tell you about this. Now, what we're going to cover is just about understanding SQL Server strings in some depth, and mostly we'll be looking at demos. So let's start with the character data types. Now, the standard built-in SQL Server character data types are these. So there's a char data type, which is a fixed length, single byte and UTF-8 character data. If you don't know what UTF-8 is, we'll talk about that later in the session. nchar is a fixed length, similar thing that's used to hold Unicode data. Varchar is where we have a variable length, again with single byte and or UTF-8. We've got nvarchar, which is the variable length Unicode version. And interestingly, there's varchar max and nvarchar max that are the large value versions of the same thing. And it's an interesting concept first up, is that varchar and varchar max are actually really different data types. And similarly with nvarchar and nvarchar max, even though in many cases they're very, very functionally equivalent. Finally, we've got text and ntext. Now, these have been part of the product since the Sybase days. In SQL Server 2005, we were told to stop using them and to start using the newer versions instead. So, for example, the text data type, they said use the varchar max data type instead, and for ntext, use the nvarchar max. Now, the large value data types allow you to have up to 2 gigabytes of data in a single string, which is a lot of data, obviously. Now, there's a big difference, though, between the new versions of the data types and the old ones. So let's start there by saying that when you had a text or ntext data type, the way it worked is that SQL Server didn't store the value in the row with the rest of the data. It just put a pointer in the row to a blob, basically, that was where the data was then stored. Now, with varchar max and nvarchar max, these are much more efficient because what they do instead is they default to storing the data in the row and then having overflow pages if required. They can, though, still end up with scenarios where the data is stored out of the row. So, for example, if you have a table that has an existing text or ntext column, you might think you can just fix the data type by doing an alter table, alter column, and just changing the text across to varchar max. The problem with that is it will change the data type, but it won't move where the data is stored. And so, unfortunately, there's no good option for that. You really have to remove the table or maybe rename it, create the table again and populate the data in. So it's not quite as elegant as I really wish it was. But it's much more efficient to use these new data types, because what I see more and more is that people use varchar max and nvarchar max to store all sorts of lengths of values, including things that are quite short. In fact, some developers now, it's a real bit of a pain really, is that they end up having almost every column as varchar max or nvarchar max, and they just treat it like a string and say, if I have something that's string to store, I just put it in that. Now that's not a good idea, and we'll talk more about that later. But the first message is if you have text or ntext, you need to move on from those. But let's have a look at what these data types really mean. Here in SQL Server Management Studio, let's declare @value, and we'll make it of type char10. Now, since SQL Server 2008, we can initialize that in the same statement. So if I say hello in here, and then if I select back, no big surprise that what I get back is hello. But what's not immediately obvious there is what I'm really getting back. So let's add something on the end here so we can see the boundary of what's occurring. And if I execute that, notice that I've got the hello, and then I've got a bunch of spaces at the end. And so this is the first thing that's really important to understand, is that if you use char, then it always returns the length that you say. So if I say char 10, I get 10 characters back. If I say char 20, I get 20 characters back, and so on. Now clearly, that isn't necessarily what you want all the time. And in fact, I've worked on systems where they tend to have everything declared as char. And that's a problem, because you spend your life needing to trim the values that come back. So you end up having to say something like rtrim to do a right-hand trim of that value, and then to get back the one you want. Now, since SQL Server in recent versions, we could also just say the word trim nowadays, and that would do a left trim and a right trim of that value. Now, one of the things that might surprise you a little bit though, is that if I also said, what's the length of that value, notice it's 5. And so even though the string contains 20 characters, it only gives you the characters without the trailing spaces for the length of the string. Now that's a little confusing, because notice that the length of this thing up here would be 22. And that's because it returns all 20 characters, and then we've got a character either side of it. So that for a start is a little confusing. Now you might think that that's just because it's padding on to the end of that. What if I had put spaces in there myself? So if I add a few spaces onto the end of that, let's remove this, and then look at the length, note it's still 5. Now this is something I really don't actually like, because to me the length of that string is not 5. And so if you look at what you would have to do to calculate the real string length, that's a little bit messy, and in fact we'll come back to that later on. But what a lot of people want is they don't want the padded spaces on the end of this coming back to the full length. So let's remove this and then say, look, if we just did that and we changed it across for this being a varchar instead, let's go back to just being 10, and let's get rid of those for now. And then we said, look, what's the string returned? It's just that. So the first essential difference is that varchar is just going to return the characters that have been used. Now, there's overhead in doing that. It has to put a counter at the beginning of the stored value to say how long the value is, but it's then just storing the characters that are needed, not the whole thing. And so, look, you might also be thinking, well, hang on, that's a good space saving over the char data type, because it's storing all those extra spaces. And in earlier versions, look, that was true, and it still is a bit true today. But as soon as you do any form of compression, like row compression or page compression, that's going to be removed and you're not going to have that overhead. Now, I'd suggest you should be using table compression. In fact, I think row compression should be your default, and you should be using page compression in certain scenarios. But let's just imagine for the moment that's not there. In that case, we're still just storing, if we don't have any compression, we are storing the sort of full length of that thing. Now, one thing to understand there is we said that varchar ends up having a little overhead, and I said that because of that, you'll find some people get very, very nervous about the wasted space, and they'll end up saying, look, char1 instead, if they have a value that's just like a yes and a no. I'm not actually a fan of that, because sometimes that yes and no might be a blank string. And the problem is with char1, you get back a single space. And to me, the space saving on that is so irrelevant. And most of the time, when I see something that's char1, it probably shouldn't be a character anyway. It should either be a bit, and often it could be some sort of integer code or something. But anyway, so the idea is that we have char and we have varchar in there. Now, if we look again at the length of this, so if I said this is varchar 10 and I put some spaces on the end of that, and then we look at what's returned. So first up, I do get the spaces back, so it doesn't truncate them off the end of a varchar. And notice though that the length is still just 5. It doesn't include those spaces that are on the end. Now this is all well and good, but the next thing you've got to think about is what are the characters that can go inside this string? The basic rule here, of course, is these are effectively ASCII characters. I brought up here the ASCII table. Now, this is the values that we have. Because we have a single byte per character, we have 256 possible values. So they go from 0 to 255. Now, if you look at what's here, the bottom ones, from 0 up to 1F there, which is 0 to 31, these are the characters that are our control characters. So carriage return, line feeds, things like that. Then we have some punctuation in the next set of characters. We have the digits, some greater than and less than signs, and then effectively we have the uppercase alphabet and the lowercase alphabet. Note that they're 32 apart. So the difference between a capital A and a small a is 32. This actually makes it really, really easy to do conversions between uppercase and lowercase. But then this is up to 127. The question is, what's in the top half of the byte? It's important to understand that in the early days, there wasn't an upper half of the byte. In fact, ASCII itself grew up to 7 bits first up, but it didn't always have 8 bits in this. In fact, there were many computer systems that stored 7 bits per character, and that's all they had. So I used to work on some old VAX systems where they had a 36-bit word, and what they stored were 5 characters plus a parity bit, so they were 7 bits long. There was no upper half. But ever since we've had microcomputers, we've had an upper half. Now, in the early days of computing, most people never used those characters. So there were a couple of reasons for this. The first thing is there was no easy way to type them on a keyboard. Now, you might realize in Windows you can hit Alt and then type, say, 174 to get character 174. But it's not like it's a basic key that's just right there on your keyboard. The other problem with them is originally there were no standards for this. And so this is another big reason why people didn't use it, because you might have a character set in your screen that had a different character set to what was in your printer. And so I might put a character on the screen and it looks fabulous. I printed it out to the printer and I got a different character. So that wasn't particularly useful. Now, when the PC came out, it had a very basic additional character set. And so these are the extended ASCII table nowadays. And so note what it is. It's a bunch of European characters with accents and graphs. It's also got line drawing characters and a few other symbols and shapes. Now, the first thing about this is that if you did speak a European language, you really wouldn't want the A's not to be down with the rest of the A's. Having them off separately like this up the top is not particularly convenient. You can imagine when you're sorting and so on. This is sort of a real challenge. And the fact that there weren't standards meant that when they introduced DOS in Windows, they didn't really want to force a particular standard, so they allowed you to have different layouts of characters, and that's what code pages are. So if you see a thing that says which code page, what they're really saying is which set of characters are we using in a byte. Now, the bottom half is pretty much standardized across all of the industry, but the upper half can still be different if you have different code pages. So if I said in this one shown here that, for example, 130 is an E with an accent, that could be a different character in a different code set. So if you ever use tools like integration services and you're doing movement of data between one system and another, if it's an 8-bit character, a single byte, what it always is asking you is not just how long is that string, it's asking you which code page, because it might need to do conversion on the way across. Now, the other thing to realize is this is a tiny, tiny set of characters. This is not suitable for worldwide use, right? Now, there originally were specialized versions of ASCII. There was a Japanese ASCII, there was a French ASCII, and so on. But they've sort of all fallen by the wayside, because what we really want to do is store all the characters properly. There was a project back in the 1980s where they looked at this and said, if I want to store every character from every possible language, what do I need? And the answer was 3 bytes. Not 2, 3. And at the time, we had mostly 16-bit computers or 2-byte computers. I can tell you no one wanted to hear an answer that said 3 bytes was going to be needed to store a character. So when Unicode first appeared, it was basically a compromise that sort of squashed all of those characters into 2 bytes. And so there was what they call the multilingual plane of Unicode was basically 2 bytes or 65,000 characters that we could use to store characters from other languages. Now, the challenge with that is that some of the languages have a lot of characters. One of the things I've been doing for a number of years is slowly learning Mandarin. And if you look at Chinese characters, I think if you look at all the old characters and the new ones, there are probably around 30,000 characters. That's a lot of characters. And there's a similar number when you look at languages like Japanese. In fact, they have multiple character sets. So they have hiragana and katakana, but they also have the kanji, which are the old Chinese characters that are part of the language. And so it's really easy just between Chinese and Japanese to already blow away the entire range of possible values in Unicode. So you need to understand that Unicode, when it appeared, was a significant compromise. In SQL Server, we can use those characters. So for example, instead of typing the ASCII characters in here, I could add additional characters in, let's say, Chinese, and put that in my string. First thing you may or may not have thought about is if you have 30,000 characters in a language, how on earth do you type them on a keyboard? And so we have there are different input methods. So notice down the right-hand corner here, I've got English. And if I pop that up, I've got English Australia, English US, I've got simplified Chinese, and I've actually got a Japanese input editor as well. I can just click on that, and that puts me in a mode where I'm entering Chinese instead. The other way I could have done that is held down the Windows key and hit the space bar, and that changes between the languages. And now I can type Chinese instead. Now, what they have in Chinese is they have a thing called pinyin. If I type HEN, then what this is saying is show me the characters where this is the pinyin. Now, all of these characters that have popped up there are that character. Similarly, if I said MA, notice the set of characters that are coming up here. Now, the first one is equivalent to a question mark. The third one, another simple example, that's a horse. And notice there's an emoji there nowadays for a horse as the fifth one. The fourth one is a mother, and so on. So if we want to say hello, then the thing that people always learn in Chinese for hello is ni hao. And so if I said ni, notice I get a choice of characters there, and so I can hit that, and it pops that character in for me. If I said hao, I can drop that character in as well. So notice I can type that fairly quickly. The other thing it does do, though, is it understands the characters so that if I typed both of those together, I don't have to go and pick the different things that it could be. It finds combinations of characters that are the most likely things that go together there. And I can then just hit one and it pops those characters straight in. There are other ways that you can find characters. So to give you an example of that, if I take this character here and you look at it carefully, you notice there are really two characters there. And so the one on the left is actually the character for a woman. The one on the right is the character for a baby. And together, though, they make the character for good. I actually think that's really sweet. Anyway, but they're treated as a single character in that case. Now, notice that if I run this that we had before, let's remove that for now, it doesn't work when we get this back. The first thing you might think is, well, hang on, I'm not storing that in an appropriate location. So if I said put that in an nvarchar location, now I need to be back in English to do that properly. So I'll say nvarchar there, and notice if I run this, it still doesn't work. And the problem is that I'm missing an N here. And so the idea here is that when I have single quotes around a string, all I can have in here are single byte characters. But if I put an N outside it, it says between those two single quotes, I can have multi-byte characters in there. And so notice if I do that, it then works as expected. If I hadn't stored it in an nvarchar, it also doesn't work. And so the first thing is that N's really important if you're doing multi-byte character strings, and that's why you see it all over the place. Because in SQL Server, the default for most things nowadays tends to be an nvarchar. In fact, if you have the name of a table, or if you have the name of a column and so on, the data type of those is actually called sysname. And that's actually an alias to nvarchar 128. So if you write the name of a table, you should not be just going table name inside there. You should be going table name inside there. And so this means that you are allowing for the fact that it could be a multi-byte character as part of that name. All right. Now, once we have that, you might then think, okay, well, that works. What about the length of it? So if I said select the length of that value, note I get back 2. So it's understood that this is 2 characters coming back there. But clearly, it's not 2 bytes because each one of these is a multi-byte thing. And the function we have to find that out is called data length. And if I say, give me the data length of value, I get back the value 4. And so this is the basic manipulation when working with these data types. Okay, now that we've seen how these basic data types work, the next concept I want to cover off is collations. Most people see them, but often don't really know what they're there for. So the idea of a collation is to determine the way things get sorted. And so there's multiple parts to this. So a collation includes the code page if you don't have Unicode data. It gives you the rules that are used for sorting and comparing, and it gives you case and accent sensitivity options. And so if you look at the example below, it's got a collation there, and it says SQL Latin 1 General CP1 CS AS. SQL on the front of that immediately tells me this is an old collation that came from SQL Server back from the Sybase days. We're really not meant to be using those collations anymore. And the Latin 1 General is the character set and so on that we're using. Now, there is a collation with basically the same name, but doesn't have the SQL on the front. So if you see collations that don't have SQL on the front, they're the Windows collations, and they're the ones you should really be now using. It then shows CP1, which curiously is code page 1, which really isn't code page 1. It maps to the standard US English one. And they've then got CS for case sensitive and AS for accent sensitive. So in this case, we're saying that if a capital A is part of a word, that's different to a little a in the word. So if I have McDonald with a capital M and McDonald with a little m, they're different. Now, I'm not a fan of case-sensitive databases. In fact, I think they're one of the most horrible things you can do to users, but some people need them and some people use them. So you need to be prepared for that if you have those collations in place. And sometimes you might want to use them just for a single comparison. So in this example here, we're saying we're product like corn, but I'm looking for exactly those upper and lower case matches. I can specify the collation on the end of the like, and that says use this rule when you're doing the comparison. The final one on the end there says AS, and so that's accent sensitive. So that is an A with an accent or an E with an accent different to an A or an E without an accent. There are also Kana and width sensitivities and so on. There are others, but they're the main ones that you'll come across. Now these can be set at the instance level, so for a whole server basically, at the database level, so that you can have a default throughout an entire database, but you can also set it at the column level. But notice there's no option to set that at the table level. I mentioned before that the ones that start with SQL are the old Sybase collations, and we shouldn't be using them anymore. We'd prefer to use the Windows collations instead. So let's have a look at collations. Now I'll remove this code I had before. One interesting thing, notice that when you declare a variable, you can't declare the collation for a variable. I actually think that's a missing aspect of the product. I wish you could do that. Variables end up taking the collation of the database that you're running the code in. Anyway, so let's grab this here. And so if I said select, in fact, let me say if A equals A, print yes. Let's just do that. And so note I get back yes. And that's because the collation I'm using has allowed the fact that it's not case sensitive. If we look at the available collations, you can see those. If I say, look, select Asta from sysfn help collations, you'll see the number of collations supported in SQL Server. And note down here at the bottom right, there are currently 5,508 different collations. So that's a lot. Let's try and find those Latin ones. So if I said where name like, and let's go Latin 1. So I've got Latin 1 general bin. So this is a binary collation. Now let's have a look at that as an example. So if I put on the end of that comparison, collate, like that, and then we execute this, notice I don't get the yes. So they're now different things because I've said use a binary collation for that comparison. Where most people come unstuck with this is when they use temporary tables. So if I say create table hash some name, the question is, what collation would be used by default for columns in that table? Now you can spell out column by column exactly what the collation should be, but there is a default for this, and it's going to be whatever tempdb's collation is. And tempdb will have the same collation. It is weirdly possible to change it, but you shouldn't do that. But it will have the same collation in the end as the instance that it's installed on. Now, where people run into a problem is they then create a temporary table in their application code, and eventually they need to join that to something that's in their own database code, and the database has a different collation. And so they get a really, really common error message that says unable to resolve the collation conflict between the values, and they find that what they need to be doing is specifying a collation. And so really, if you're working with tempdb, you shouldn't be complaining if it's different to what your application database is. You need to accept that if you're doing work with temp tables, you need to be specifying the collation to be used for comparisons every single time you compare a value in a join, in a where clause, or if you're having less thans, greater thans, things like that, it needs to know it. If you don't want to spell out a specific one, what you can do is you can say database default. And so that then says use the default collation for this database for doing the calculations. Now, for a very long time, that's all there was to collations in SQL Server. Well, I mean, there's a fair bit to it, but that was the whole story. In 2012, though, they added what are called SC collations. So these are supplementary character collations, and they were supported on some data types, so nchar, nvarchar, nvarchar max, and SQL variant. But what they did is they changed the definition so that when we had an n in front of a string and between the quotes, we used to have 2-byte characters that lived in there. So you had multi-byte characters. This allowed you to have 2-byte or 4-byte characters in there. And you can see the collations because they've got an SC on the end. You're allowed to do this for columns, but you can't do it for servers or database collations. Now, if you look at a character like nchar and 0xD83D, that returns a specific character. And similarly, I've got another one over to the side there, DC3C. But if you select the two of them together, actually get a different outcome. And as a hint, here's my friend Snow, who lives in our backyard. He's not real, but I'll show you how he fits into the story. So we'll take a look at SC collations. If we go back here and we have a look at this help collations, if we said where the name is like %_SC, then you'll see there are currently 1,488 collations that, if you look at the end of the name of them, you can see involve supplementary characters. So these are ones that can deal with those length of characters. And what I want to show you is that if I said that, where we select both of those characters, notice that we get something that's sort of suggesting, yeah, that doesn't really map to something useful. But notice if I add them together, which is a curious sort of thing to do, and I select, notice I've now got my little panda appeared. And this is an example actually of emojis. And so this is a way that we can get to characters that are not in the normal range of characters that we could otherwise be using in SQL Server. And then you might think, well, hang on, what does that do to things like length? So if I said, what's the length of these two together? Notice it still says 2 characters, even though it's really a single character that comes out. And if I said, what's the data length? It's 4 bytes coming out, which is no surprise because this was 2 bytes and this was 2 bytes. So from 2012, they added this ability to get to other characters, but they knew they needed to do more. This then brings us to the topic of UTF-8 and additional characters. Now, when they did Unicode, we said they realized this was a compromise. We only had 2 bytes to store a character in, and that was nowhere near enough. And so what they did is they expanded this. So it's important to understand that Unicode was not an encoding of data, it was a character set. And then we could encode it in different ways. So the way it could be stored is not really related to what the character is. And so the first thing they did is go and fix a whole lot of the issues that we had with Unicode. So for example, the values from 0 to FFFF were the bottom 65,536 values, and they called that the multilingual plane. Then they went and fixed most of the issues with that in another 65,000 character plane that they call the supplementary multilingual plane. So they fixed most of those basic problems. They then took another plane that they call the ideographic plane, and they also allocated a special purpose plane and a private use plane. What matters about this is that you're going to start see characters appearing in computer systems that you've never seen before. So for example, things like musical notes will become characters. In fact, there's been a big project a couple of years ago to go through and write down and use all of the standard emoji that we use and turn them into standard characters. All of these things are becoming standard characters in a computer system near you. And so the issue is, how on earth do we store something that might have all these possible values? So we need to look at a way of encoding it. Now, we don't want to use 4 bytes to store every character. No one wants that as the answer. So what the thing has been really popular in the industry now for some time is an encoding called UTF-8. And so note, this is not a character set, this is an encoding method for Unicode. And so it stands for Unicode Transformational Format in 8-bit. And the idea is that each character consumes a certain number of bytes depending upon what the character is. And they designed it so that our most common bottom 7 bits of ASCII, so our standard character set, still only occupies 1 byte. And this is really, really useful because it means that you can store all these different characters, but we don't pay the penalty of having 4 bytes per character. And valid ASCII text is also valid UTF-8 encoded text. So there's nothing different about the encoding when you're dealing with the standard values that we in English use all the time. The basic encoding is that if it fits in the bottom there, it just occupies 7 bits. But as soon as it goes beyond that, we can then have 2 bytes involved. And then there's another whole range where 3 bytes are involved. And finally, another range where 4 bytes are involved. And the idea is they use the top part of the byte to determine which part of the value you're looking at. And so the beauty of this is that in a string, you can have values that are 1 byte, 2 byte, 3 byte, or 4 bytes in a single string. And it's using the smallest sort of size that it can really get away with to store those characters. So let's have a look at how that works in SQL Server, where it's recently been added. The first important concept with UTF-8 is that it's stored in varchar columns. It doesn't require nvarchar columns. So note here, I'll say use tempdb, and I'll drop this table if it exists called character test. I'm then creating a table, and I've said give me an ID, and then I've said here's a data value, is the name of my column, varchar 50, but I've used a collation, note that ends in UTF-8. So if I create that, it's all good. And then if I insert, what I want to show you is what happens if I use the n and what happens if I don't use the n. Now, both of those will insert, but if I then select the values back, note that one of them worked and one of them didn't. So in this case, I still needed the n to be able to get the value to go in, but I am storing it in a varchar column. This is the key difference. And the reason that that's still required for the n is that if you don't use the n, it's taking that string that you typed in, turning it into a single byte constant string before it's assigning it to the character location where you're storing it. Where here, this says, hey, I know this is a multi-byte string, and it's going to preserve that until it does the insert, and then it can insert it in this column. And so, as I said, if we select that back, we then see this one worked, even though it was to a varchar column. Now, this is nice. This is quite good. There's things I don't like about how this has been implemented, though. So note if I say, give me the values and give me the length and data length. So note here, that one didn't work, and so it was just 2 characters long that were turned into single byte characters, and so it's 2 characters long and the length of it is 2 in bytes, with no surprise because it didn't really work. But this one here is now 2 characters long and it's 6 bytes long. This is all great, but where the confusion comes in is with this. Now note that says varchar 50. Most people I talk to and most developers think that that means I can have 50 characters, and that's not the case. So if I said varchar 10 here, what I'm saying is that column can store up to 10 bytes. To me, that's surprising and not what people are expecting. In fact, in other databases like Postgres and so on, that still means 10 characters. When they introduced this, the SQL Server team said to me, oh no, it's always been that way. Well, to me, maybe yes, but it was irrelevant because if I had varchar before, whether it was 10 characters or 10 bytes, that's exactly the same thing. And what's curious about that, of course, is if I said in varchar 10, then I was actually saying 10, most people again thought 10 characters, but this was 10 byte pairs. So that was actually 20 bytes were being able to be used for that nvarchar. And in fact, if you used in SQL Server 2012 an SC collation, you can have situations where you could not fit 10 characters in there because some of your characters might have been 4-byte characters. What it means today, though, is that if I say varchar 10 and I'm using UTF-8, depending upon whether they're single byte, 2-byte, 3-byte, or 4-byte characters, I could fit anywhere between 2 and 10 characters in that, and I don't know how many fit until I know what the characters are. Now, for me as a developer, that's not really what I want. I want to limit it to 10 characters, and there's no easy way to do that. What we've asked the SQL Server team for is maybe they could put the word characters in there or something like that. I really would prefer they actually fixed it and made it work the way I think it really should work, because I don't see any value in putting a byte limit there, because to somebody using the database, that's completely irrelevant. The other sort of options then, if you're saying, well, I really am wanting to limit this to 10 characters, what on earth do you do? And so, I could say, well, I just declare every string as varchar max. That's not really my favorite thing to be doing. But then I could add a constraint on this column where I limited the length of the characters in that to 10 characters. But then you got the problem that the length function doesn't work properly because it doesn't count trailing strings. So again, the what you'd have to do is build a constraint that takes the value in the column, appends another character onto the end of it, gets the length of the whole of that, subtracts 1, and then sees if that's less than 10. Can you imagine doing that for every single column in your table? To me, that seems really ill-conceived. However, that is how it works today. So it's important to understand that. Now I want to finish out with a final section where I just show you a few string functions. I find there are a number that are not well understood, and even though you mightn't think T-SQL has changed much lately, there also have been a number of new functions. And so let's have a look at those now. The first function I want to call out is concat, and also concat WS with separator. We've been able to concatenate strings for a long time. So if I said select hello plus there plus now, then it doesn't pad it or anything. That would just put the strings one after the other. So I could put spaces in there. I can say, yep, that's fine. Just join the strings together. But one of the problems we've also had is that if one of these values was null, then notice you end up with null for the whole thing. And one of the useful functions that got added back in 2012 that I don't see a lot of people using yet is concat. And so concat says, look, take a list of values. Let's put that null in there as well. And if I execute that, notice it's appended the strings together, even though there was a null in the middle. In fact, let me get rid of the space so that we're not having the space confuse us. The thing that this does is it takes values, a list of values, it implicitly casts the value to a string, and then it also ignores nulls. And so if I said in here 5, 12, like that, notice it's implicitly converted the 5 and the 12 to strings, and then it's concatenated them all together. This is pretty cool. I actually really quite like this as an option. That's been there since 2012. I don't see all that many people using it, even though I think they should be. But an interesting addition got made in 2017 where you could say WS, and what that says is give me a separator. So for example, a comma, and then that returns you the values in the list with the separator in between them as it does the concatenation. One thing I don't particularly like here is that because it ignores nulls, it leaves the value out. So I can't really quite use this to generate a comma delimited string effectively if I know one of the values might be null. I would still have to use an is null or something in the middle of that. But overall, this is kind of neat. Another function I want to draw your attention to is quote name. If you have code where you're maybe saying, look, table name, and I mentioned earlier that the right data type for that is a sysname, and I said, look, my table name is customers, and maybe I've got a schema name, sysname, and I'll call that DBO in this case. And if I had to generate a script using those values, what I see people will do all the time is they do this. They get the schema name, they add on maybe a dot or something, and then add on the table name and so on, well, you know, which works. I mean, it's not like that doesn't work, but there's several things wrong with this. So the first thing is that this should be Unicode, so I should have an N in there. And when you run that, you're not really going to see any difference. But imagine if in here I had a value that, you know, is going to be problematic. So for example, I had a space in the name middle of that. Now, I'm not suggesting that's a great name in this case for that table, But note that what I get back is not something that's going to be usable like that. And so whenever you're building code that builds code, it's really important to remember to use quotes around it. Now, again, I see people do this. And if they remember to use Unicode, they do that. And then they go in here and then say, oh, in fact, just in here, stick in a square bracket and then, a closing square bracket, and so on and so on. Don't do that. And so there is a built-in function that does this for you called quote name, and it automatically puts the quotes around the name. And it does the right thing. So if we did that and execute, we get this back. Now, what I really would prefer, obviously, is a function that quotes the name only if it's necessary. I hate reading code where all the square brackets are all over the place. But at the moment, that's the safe thing to do. I really wish there was an option where it would put the square brackets there only if it needed to be there. So that would be if it has a space in it, or some character that would be a problem, or if it was a reserved word. Then in that case, I wish that was there. But don't forget about quote name. It's an important function. String escape got added a little while ago. So note if I have, let's say, declare a value, and I'll make it a bunch of characters, and I'll put some punctuation and things in, and backslashes, and things that might be problematic if they were passed to something else. So I can say string escape, and then put at value in this case, and then I need to put the escaping mechanism that I want to see used. Now, the only one that's allowed at the moment is actually JSON. And if we execute that, notice that has actually gone through a note. In this case, the backslash, it's decided that needs to be a double backslash, and so on. So this will escape it for you like you need it for JSON. A function that's been around a while is ASCII. If I say declare at value as a varchar 1, make that A, and I say select ASCII at value, that tells me the ASCII code for that value. But note there's also a Unicode function where I can do the same thing with this. So if I created a character with a higher value, so let's say, for example, in varchar 1, and I'll say this is an nchar, and let's make it the value 194. I have no idea what that is. But if we then said, what's the Unicode of that? For example, that's the character 194. But we could go up higher with this and go right up through the Unicode range. In fact, it also deals with supplementary characters like we were talking about earlier. Translate is an interesting function. If I declare a value here, and I'll make it varchar max for now, and say this is something that's meant to look perhaps like a phone number here in Australia. That's not how we write phone numbers. Now, if I wanted to go through and replace the square brackets with an opening round bracket, and I wanted to replace the colon with a dash and the closing square bracket and so on, I could write code that does that. So I could say, look, replace, and I could have at value, I could say, get me that square bracket, and replace that with that. But then I'd have to put another replace, and then everybody in the past has written this sort of code, right? Where we then replace that with that, and then eventually we do another replace where we'd say, look, replace that colon when they come in, and I want a dash there instead. And that works. I mean, there's nothing wrong with that. But notice what you can do with translate. I can say translate the original string at value. I can say, here's a list of the characters I want you to find, and here's a list of values that I want you to use to replace them. The two lists must be the same length. But notice if I do that, it does the job just the same, and it's way simpler than having all those replace statements. In 2016, we also got string splitting. So if I said declare at value, let's just go varchar max, and I had a string like Greg, Mary, Thomas, Mia, and so on. And I can say select aster from string split, and I can pass into that the value, and I can say the separator is a comma. And notice I get back Greg, Mary, Thomas, Mia. Now this is fine. There's a couple of things I don't love about this for a start. The first thing is you don't necessarily get the columns back in order, because this is returning a table, and of course a table doesn't have a natural order. But what they don't do is they don't return you a column that tells you the position of each of those values. So that makes this really, really quite messy to work with from that point of view. The other one is that it's really common as well to often have bits of spaces around the values or things like that. And of course, that's going to return the values with those spaces. I really wish it had an option to sort of trim the space out of it as well. But look, for what it is, it's good and it works really fast. What they gave us just recently, though, is a string aggregate instead. Let me go and find a table here that has some columns, just so I have something to work with. So this is a reporting services database. Let's grab the schedule. So it's got a number of columns here. Now, if I wanted to script out a command where I returned all the names of the columns there, now notice what I can do. So if I said select, and I said from syscolumns as C, I could join that to systables as T. On T object ID is the column object ID. And let me go a little further, and I'll also say inner join sysschemas as S. On S.schema ID is T.schema ID. Okay, so that's giving me the table, the schema, and the columns that are part of that. Now I'll change over to doing this in the report server database. And so I could get a list of the columns from this table. So let's make this where S.name, the schema name, is DBO. And even though it's not 100% required, I tend to quote things that change color. And I could say, and the table name is, it's called schedule. Now, if we did that and said, I just want the column name, and I execute that, I can get back a list of all the columns in that table. But what I might want is a single string with them with a comma between them or something like that. So I can say string ag, that thing, and then I want to give you, here's the separator. And if I do that, notice I then get back a single column where it's aggregated the string. This sort of thing can be incredibly useful. And so that's just a quick summary of some of the string-related functions that I think either have been ignored by a lot of people or have been recently added. So let me finish by thanking Microsoft and the Data Platform Geeks team for letting me be part of this, and Microsoft for supporting this conference in the first place. I'd really hope you all don't be strangers. I've put contact details there. You can email me. We have a whole lot of free stuff at our site if you want ebooks from me or podcasts or things like that, or the SDU tools that we use. My blog is linked there. And if you want to learn something from me, I've got training both free and paid in there. And so finally, thank you for being involved in this. There are a bunch of ways you can win prizes as part of this event, and so I'd like once again just to thank you all for being part of this.